In this video, we're going to go over HR diagrams. So where do the different regions of star formation go on the graph? What are the axes, because you need to know how to label them, and what even happens in star formation. So hopefully everyone's aware that star formation always begins in a nebula. Okay, so a nebula is just a cloud of gas and dust. And what happens is we know gravity always pulls things together in mass. So gravity pulls all that cloud and dust together, and as it collapses in itself, that gravitational potential energy gets converted to the thermal energy, and it starts to heat up, heat up, heat up. And eventually we get what we call a protostar. So that's the beginning of the star, the birth of the star. And as soon as that core heats up enough, that hydrogen fusion can start to happen. That's when we get a main sequence star. So that's what our current sun is. It's a main sequence star, hydrogen fusion. And it's stable because the outward forces of the radiation is balanced by the inward gravitational forces. Okay, if it's a star like our sun, like we just said in our current life cycle, what's going to happen after our sun finishes its hydrogen fusion into helium, that core is going to collapse in itself. And then the outward layers, they basically swell outwards and expands then to form a red giant. Okay, for our sun, this will lightly cover up the most out past Mercury, it would just expand outwards. Okay, so it forms a red giant. After a red giant, then what's going to happen is those outer layers are just going to pass on out into the universe, right? So just going to pass on out, they just kind of get released, okay? And then what gets left behind is that middle part, which is called the white dwarf. And after a really long time, that cools down to form a black dwarf. If it is much bigger than our sun. So we're talking here about 8 solar masses, and sometimes we can write solar masses like this. If you ever do astrophysics at uni, hopefully, that's how we represent a solar mass. So let's say it's bigger, or around 8 solar masses, 8 times the mass of our sun. What's going to happen is it's going to form a red supergiant. Okay, so much, much bigger than a red giant. And that red supergiant, what's going to happen is when the core collapses, it basically rebounds, and it creates a supernova. And what a supernova is, it's just a rapid increase in its brightness. So supernova is like an explosion, a rapid increase in the brightness. And after that supernova, what gets left behind then is either a neutron star, and a neutron star is exactly that, it's just made of neutrons, or a black hole. If the mass of that star is around 20 times the mass of our sun, that's the ones that are more likely to form a black hole. And when they supernova, they actually release gamma ray bursts. Okay, they release gamma ray bursts. Okay, so how to put this all under HR diagram? Okay, the way I remember anyway is the earlier video, we learned about Hipparchus scale, so look back in that if you need to. But the Hipparchus scale, remember, is from 1 to 6. So it's all positive numbers. So the positive numbers are always higher. So that's why we always go from positive 15 to negative 10. So it's higher on the positive end because the Hipparchus scale is more positive numbers. Okay, then you just fill it in. So positive 10, there's my positive 10, my positive 5, my 0, and my negative 5. Remember, we remember that the more negative the numbers, the more brighter they are, right? Because Hipparchus classified the stars we can see with our eye, and then clearly we can see much more brighter stars than the class 1 stars. The more brighter things are the negative numbers. At the bottom, we put our spectral class. So that's when we have our O, B, fine, girl, kiss me. Sometimes it'll have temperature in the bottom, but you know roughly that an O-class star is around 50,000 degrees Celsius to an M-class star, which is around 2,500, okay? And our own sun is around 6,000 degrees. That's our G-class star. So that's the first one you always want to pop on, is our G5. Our sun is currently a G5 star. So that currently is where our sun is. And like we said before, it's a main sequence. So you have to make sure when you're drawing this, you make sure that when you draw your main sequence, that your sun is within it. So these are your main sequence stars, kind of like a bit like a shelf. Okay, so these are all my main sequence. Okay. What we said was our red giants, remember we said it's going to expand. So red giants, they actually get slightly cooler, okay, because it's not hydrogen fusion. They get slightly cooler, and what happens is they get slightly brighter. So our red giants, our red supergiants over here. And just make sure that you never go higher than negative 10 or lower than that positive 15. Down here then, that's where our white dwarfs are. So white dwarfs, and these are our red giants. Okay, white dwarfs and red giants. The only thing you might get asked to do then is how to draw the path of maybe a formation of our sun or the path of a star. So what's going to happen is our star, remember, starts as a protostar, so sun's going to be much cooler and much dimmer, and it's going to form the main sequence. Once it forms the main sequence star, what's going to happen is we know that it's going to slightly cool down and it's going to get more bright to form our red giant. After it forms a red giant, it's going to heat up and become less bright, so it comes down to our white dwarf. So that roughly is the path that our sun would take from birth until it forms our white dwarf, and then after that would form our black dwarf.